Our next speaker is Yasuyo Minagawa, and so we'll be talking about voice, reward, and language, brain responses to maternal speech in infants at varying risk of autism spectrum disorder.
Thank you for the introduction. Hello, everyone. I'm happy to share our small FNU study on infants at varying risk of ASD. Mammalian infants were born in a very vulnerable state. So maternal mother-infant attachment or maternal stimuli are crucial for their survival. In the case of human infants, maternal stimuli also have additional role, essential role, that is fostering communication ability. Through interaction with parents, infants acquire language and learn how to communicate. So actually, many studies reported that maternal signal facilitates infants' language and social development. For instance, there are advantages in word learning, facial emotional recognition, and so on. And some neuroimaging studies also reported stronger brain activations and more sophisticated network in response to mother's speech. I will show you our previous results quickly. So we tested neonates' brain response to mothers and strangers' speech. And as you see here, neonates showed larger connectivities in response to mother's speech. But what about children with SD or infants at risk? It is known children with SD and infants at risk for SD show weaker brain responses to human voices than neurotypical controls. However, no study has investigated differences in neural responses to maternal versus familiar speech in infants at risk for SD. So the present study aims to investigate differences in cerebral activity and connectivity in response to maternal versus unfamiliar speech between infants with low likelihood and elevated likelihood of ASD. And the second aim is to examine how early neural responses to familiar voices may influence subsequent language and social development. Methods. Our FNUS experiment included participants of 6 to 7 months old infants. They were EL infants and LL infants. So EL infants are sibling infants of children with ASD. Our stimuli were 15 seconds of infant-directed speech spoken by mother and stranger, female stranger. So we used block design, as you see here. Then we used FNUS system to measure temporal parietal area, and like this. Then we analyzed activation using oxyhemoglobin changes, and also we analyzed connectivity using phase locking value. We also had a behavioral test using Kyoto scale of psychological development. It's a very popular developmental testing in Japan, and also CDI language questionnaire. Here are results. This is brain activity to mothers and strangers' speech in LL and EL infants. And as you see here, stronger and broader activities are seen in response to mother's condition only in LL infants. And we can see significant activations in OFC and SMG and SDG, including in the posterior language area. This is stronger than this unfamiliar condition. In contrast, EL infants almost didn't show any positive significant activities except for one channel. And based on these results, we decided to use OFC and SDG as a seed to analyze functional connectivity. Here are results for LSDG during listening to mother's speech and stranger's speech. And I have to point out that we had a very interesting connectivity between IFG and STG. So this may reflect a kind of language network, but this cannot be seen for other conditions. And as for the right STG, I have to point out one important connectivity from right STG to OFC, left side. So maybe we can assume analyze the voice as familiar using STG. So this channel include auditory area, and maybe this is reward worthy for them. So there is this kind of connection here. And next, we wanted to analyze the effects of such brain responses and connectivities on language and social ability at 6 and 9 months olds. Basically, we found only LL group showed significant positive effects of brain responses, as you see here. And one of the examples is this one. So activities of left STG had significant effects on language and social score at their age of 9 months, but that is only for LL group. So we also analyzed the same thing using a connectivity measure. And here again, we found overall significant effects of connectivity are more prominent in LL infants, showing 9 significant connections than in EL infants. I show you two examples. So the connectivity between IFG STG here and IFG OFC here. This connectivity had a significant main effects on language understanding score at the age of 9 months, only for LL group. Then, okay, so now we move on to so the results so far was kind of experiment one. Then after this, we followed them up. We followed participants' language and social development at these ages by using developmental testing and language questionnaire. And then we applied GLMM analysis to examine the influence of brain responses connectivity on language development. We used 3 fixed effects, 3 factors. One, brain response and connectivity, age, and group. Then I show you, we found a significant interaction for these 3 factors. So I will show you one example from left OFC. Left activities of OFC had a significant main effect on language social scores, but it's only for EL infants at the age of 36 months and 24 months. So this means in EL infants, the influence of brain activity related to the OFC and IFG or STG emerges later in development. So you can see the slope is getting steeper for EL infants. Then I will show another type of graph based on the 3-way interaction. So this is about our OFC response, but these results just indicate the time course of language and social scores for LL infants and EL infants. EL infants showed a significant difference at the age of 3 years old, but before that, there is no significant differences. But now we know we had a 3-way interaction related to OFC activity. We divided them into 2 groups based on the OFC activities. These are based on the simple slope analysis. So here are results. So this indicates the data from infants who showed smaller OFC activities to mother's speech. So in this case, EL infants showed different type of developmental trajectory. So they started to show significant difference at the age of 2 years, and the difference got bigger at the age of 3. But in case of infants who showed a larger activity from OFC area, they didn't show any difference from with LL group. So OFC activities could serve as a kind of biomarker to predict their language development. And so why do EL infants show fewer activations and weaker connectivity in response to their mother's voice? So there are some adult studies reporting human voices as generally less rewarding for individuals with SD. But based on this, we guess the familiar voice of their mother act as a reward for the 6 months LL infants, but not for many of the EL infants. Because maternal speech may enhance attention and emotional arousal, thereby facilitating language acquisition. So I think it's time is up. But I just want to emphasize one sentence. While cognitive studies on language acquisition have very addressed motivational factors, our findings highlight the importance of FC activity as a potential driver of early speech acquisition. Okay, so thanks for your attention and happy to take any questions.
So there's time for one short question, and then, we've moved the slides, right. When the mum-infant pair was recruited, is the socioeconomical factor considered?
Actually, yes, we just took a measure of SES. So there are no differences.
Right, so no significant differences. So it was a wonderful talk, thank you so much. And you did acknowledge your group on the last slide. People didn't get to see.
I would like to thank my colleagues.
Because of time, yeah. So thank you for the wonderful presentation, but we unfortunately don't have any time for more questions.
Okay.
Do you want to wrap up?
Thank you. Thank you to everyone, and thank you to all of our speakers. And you'll be able to talk with them if you have any questions immediately after this, and then, of course, at their posters. Thank you again.